So let's start lesson 21. Remember, we skipped lesson 20 in all three of these remaining lessons, 19 to 23, as all different versions of the hypothesis test. Remember, in lesson 19, we looked at a theory of this is what someone's telling you is true, and you get a sample and you determine how probable is that sample if what someone claims is true. And we looked at that bowling example with mom and I forget the friend's name. Okay, we looked at hybrid cars, right? So it's what someone tells you is true versus what you see, your evidence that you see in a sample that you gathered. And we use the p-value to determine the likelihood of getting a sample that looks like that if what they say is true is actually true. And we use that p-value to determine whether we reject the null hypothesis or we don't reject the null hypothesis. Okay, and the null hypothesis is always what they say is true. You're going to get a lot of practice on the hypothesis testing because 21, 22, and 23 is all different versions of the hypothesis test. So we're doing all those same steps. The only thing that's changing in each of these different lessons is the type of data that we're looking at and how we calculate that in our calculator. And I just want to remind you, for a number of these lessons, they're doing things a little bit differently. They're talking about a test statistic, or they're showing you the formulas for how to calculate the numbers. None of these calculations are difficult. They're just time consuming. And we have these lovely graphing calculators, so we're going to take advantage of this technology. So just know that when you hear about them talking about a test statistic, that's basically getting a z-score. But remember, we have a z-score or we have a t-score, depending on if we're looking at means or proportions. And then in lesson 23, we're going to learn a chi-square statistic, which is, again, behaves pretty much just like a z-score, just in a bit of a different type of curve, not normal curve. A t is for non-normal things. Chi-square is for comparing different things. We'll get to there. But just so you know, when they're talking about that test statistic, that's really a harken back to when we had to use tables. So we couldn't get that p-value directly. We had to go to the test statistic, and then from there we could get the p-value. But that's why your calculator gives those two things. We always get a t or a z score, and then we get the p-value. We're just going directly to the p-value. Okay, we're kind of cutting out the middleman, if you will. So in lesson 21, the first page of the lesson was to just kind of review some hypothesis tests from lesson 19 before we start getting into the more complicated hypothesis tests. The review problems, I'm just going to remind you of how we're pulling out this data. This is the lesson 21 worksheet. We want to read through this, and remember, we need to write the null and alternate hypothesis. The null and alternate hypothesis come from this part here. The climatologists were interested in seeing if that tells you what follows is going to be the alternate hypothesis. They're wanting to know if it was causing an increase in water levels. My null hypothesis here is that the average depth of Hudson Bay is 305 feet, which we refer to as HO. In my alternate hypothesis, what I'm wanting to know is if there is an increase in water level. So my null is that the average depth has increased. And notice that's also written somewhere else. If you read that last sentence, can it be concluded at a 5% significance level that the average depth has increased? This also tells you your alternate hypothesis, and that is that the average is bigger than 305 feet. Remember, the null and the alternate always have the same numbers. Okay, so my null hypothesis is that the average depth is 305 feet, but the alternate is that it's more than 305 feet. And I'm coming with that idea because my sample had an average of 306 feet. So remember, the whole idea behind a hypothesis test is my sample showed me something different. Is that a representative sample? Does that mean things have changed? Or is it just a blip based on where I took my measurement? That's where that p-value comes in. That p-value that we're looking for down here is the probability of getting a sample of 306.2 feet if the average depth was actually 305 feet. Okay, we're going to assess the evidence. The evidence is always a sample. So my sample mean is 55 measurements were taken, yielding a mean of 306 feet. So n is 55, and my x bar is 306.2. And a standard deviation is known to be 109 feet. Okay, so we'd have to look back to lesson 19 to see, but we're going to use a t-test. This is a typo. This says population standard deviation. This should be the sample standard deviation. Okay, so then our S of X is 1.9. And then remember, we put that in our calculator and we get a p-value. P equals 0.005 versus our alpha, which is this 5% or 0.05. Okay, and remember, we have that saying, if the p is low, that ho's got to go. Right, so this here, this is 0.5%, which is bigger, 5% or 0.5%? Well, definitely this is smaller, so the p is low, so that HO's got to go. Okay, so what that means is my sample does indicate that the depth of the lake has increased. So we reject the HO. There is evidence that the lake is rising. The water, let's say the water level is rising. Okay, so that is the version, the quick and dirty version of a hypothesis test. You can work on example 2. It's going to be the same idea, except here we're looking at proportions, which means my null is going to be P equals something, and my alternate is going to be P is less than something. Okay, this is 0.25 because I have 25% of those eligible. All right, so let's go on to what we're doing now. In lesson 19, what we were doing is I said this is what I think is happening. I think the lake is 300 feet deep. I think I bowl 180. I think the average miles per gallon of a Prius is 50 miles per gallon. And then we get a sample, and the sample shows something different. So we are comparing that sample to the original to determine if that sample is indicative of a change or if it's just a factor of that sample. In this lesson, we're tweaking it a little bit. In lesson 21 is I'm comparing two separate things. I'm comparing a hybrid Prius versus a Tesla Prius. And so let's say, and I'm just making stuff up here. Okay, let's say the Tesla gets 55 miles per gallon and the Prius gets 50 miles per gallon. Is that a statistical difference between the two, or is it statistically equivalent? And you can kind of think back in a way, it's kind of the same idea what we talked about when we started lesson 18 with the confidence intervals. Remember, I was talking about that poll with Biden versus Trump, and Biden had 46% of the votes and Trump had 44% of the votes. And what we saw was statistically that was actually a tie because there was a margin of error of 2%. So they both had that same overlap of 44 to 46% of the vote, which means no one person confidently had more of the vote. It was a statistical tie. That's kind of the same idea of what we're doing in lesson 21, is we're comparing two different things to see, are they statistically equivalent, or is one actually different from the other one? Okay, and it's that same idea in both 22 and 23, 21 and 22. The only difference is in lesson 21, we're doing that with just two items. So one example we're going to look at is the on-time flight proportions for Delta versus American Airlines. But then what if we also wanted to compare Southwest Airlines? Well, that's once we bring in a third or a fourth or a fifth airline, we can't use the same tests we do in lesson 21. What we're going to learn in lesson 21 is strictly for comparing two different things. Okay, only two different things. But in lesson 22, we can use that test to compare 3 or more different things. We could do 20, 30, 50 different things. As long as it's more 3 or more, we're going to use that other test. So it's still a hypothesis test, but it's just comparing the two things to another. Is one bigger than the other? Is one smaller than the other? Are they different? That kind of thing. Okay, let's look at an example. I'm going to skip example 3 because of the pre-class assignment. We're going to jump into example 4. Okay, so page 4, example 4. So in Cleveland, a random sample of 73 mail carriers found that 10 had been bitten by an animal during 1 week. But in Philadelphia, a random sample of 80 mail carriers found that 16 had received animal bites, 16 mail carriers, that is. Is there a significant difference between the proportions? We want to write the null and alternate hypothesis. Now, here's the key. There's two things happening here. Remember, this last sentence tells you what it is you're finding. You're wanting to know, is there a significant difference between the two proportions at a significance level of 0.05. What we're doing is we're comparing two different cities, Philly and Cleveland. A sample of 73 mail carriers had 10 bites. The sample of 80 in Philly had 16 bites. So we've got two different things happening. Well, on the face of it, it looks like Philly had more dog bites, right? Because, well, Philly had 16 animal bites, but Cleveland only had 10 animal bites. But then you look a little further and you go, wait a minute, the sample in Philly had 6 more carriers. So is it really an increase? Because the samples are different. Proportionally, is it different? Right? And this is the problem with looking at raw numbers versus looking at the proportion. Okay, so here's what we're going to do. And in a lot of ways, what we're doing from here on is a little bit easier because the null and alternate hypothesis, there's no numbers. All we're doing is saying, are they the same or not? So here, my null and alternate hypothesis are going to look like this. Here's my alternate, is that the proportion of bites in Philly and Cleveland are the same. Okay, that's my English. Okay, so now I need to rewrite that into statistics. Okay, so in statistics, how I can write that, the first proportion equals the second proportion. Okay, but you've got to be very careful and organized about this because we need to make sure the order stays the same. Okay, so whatever you choose to be P1 and whatever you choose to be P2 has got to be the same every single time. So I like to color code this. I'm going to make Philly orange, okay, Cleveland purple. My alternate hypothesis is that they are different. Is there a significant difference between the two proportions? So I'm not trying to say that one's bigger than the other. I just want to say that they're different. So my default is that there is no difference, that they're exactly the same. My alternate then is that they're different. So how would we represent that? What symbol would I put between those two? 3 options. If it's not equal to, they're greater than, that's not what we're looking for. They're less than, that's not what we're looking for. Or they're, what's the third option? Not equal to. Our alternate is that they just don't equal each other. That's it. That's all there is to it. Assess the evidence. Remember, that's when we go to our sample. Okay, so I'm going to go to orange because I've got Philly. Again, I need to make sure to keep this straight. This is P1. Because the order I put into my calculator is going to differ. So it's a random sample of 80 carriers, so N is 80. Okay, 16 had received bites. X equals 16. Okay, now I'm going to go on to Cleveland. That's P2. Cleveland, I had N equals 73 because I had 73 mail carriers and 10 had bites. X equals 10. Now we're going to put this into our calculator. That information is back up here on page 2. Like lesson 19, for means, we have a t-test. For proportions, we have a z-test. And they're still tests because it's a hypothesis test. But now we see it's 2 to indicate 2 samples. That's what 2 samp means. Remember in lesson 19, we did 1 samp t-test, 1 sample. Now we have 2 samples. So for means, it's a 2 sample t-test. Proportions, it's a 2 proportion z-test. Okay, so we're doing proportions, so we're going to use this one here. Okay, 6, 2 proportion z-test. So pull out your calculators. We're going to go to stat, arrow over to test. Remember, all of unit 3 is stats tests. And I'm looking for 2 prop z-test. And there it is, number 6, 2 prop z-test, enter. And you see here I've got x1, n1, x2, n2, and then the order. Okay, so this is why the order is so important because the information here for X and N has to match here with the P1. X2 needs to match P2, all right? So X1 is Philly, so it's 80. Oh, whoops, don't do it upside down like I always do, remember? It's nice to have it in the order so that it looks like a fraction. 16 out of 80. Got dog bites in Cleveland, 10 out of 73. Got dot bites. We're just trying to see if they are different. Okay, so I'm going to go down to draw. Here is my normal curve. So the probability of getting the samples that we saw is in one of these areas. This means it's that one proportion was less than the other. This means the one proportion is more than the other, and this is what we call a two-tailed test. So here's my z-score, and here's my probability. If they really are different, the probability of seeing the sample we got is 0.2999, or we'll call that a 0.3 rounding up. Okay, so our p-value is 0.30. Okay, so think about, is that P low? We're going to reject the hoe? Okay, remember the saying, if the P is low, that hoe's got to go. The majority of you think, yes, you should reject that hoe. What is this part here talking about? If the P is low, what is that referring to if the P is low? Someone want to give it a shot?
It's relative to the significance level.
Yeah, what that means is lower than the significance level, which in this case is 0.05. So P is low is referring to lower than the significance level. Is the P lower than 0.05? Is 0.3 lower than 0.05? Yes, that's why I asked you this question here. Which value is bigger, P or alpha? In this case, P is bigger. And that tells me that I am not rejecting that hoe because P isn't low enough. P has got to be lower than that 0.05. And if it helps you, I find it easier to think about if I transfer these to a percentage. That's a 30% that we found. 30% likelihood of getting a sample like that versus this, 0.05 is 5%. So we're not rejecting. And anytime we don't reject, that means there is not enough evidence. These two always go together. Okay, I'm going to have you work on example 5 on your own. We're comparing Delta had 250 of 300 flights with on-time arrival, and American had 185 out of 213 flights were on time. And we're asked to find, is there a significant difference between the proportion of on-time flight arrivals between the two airlines at a 1% significance level? So do you see that we're basically asked the same exact question as we just completed in example 4, except the only thing that's different is our level of significance. We're going to be doing this a lot. So once you get solid on the idea of the hypothesis test, everything will just click into place and all of these lessons will be really straightforward for you. Okay, but let's go over example 5. Okay, so we're comparing Delta with 250 of 300 flights on time, and American with 185 of 213 flights on time. The null hypothesis is that the on-time arrival of the two airlines is the same, okay, where the PD and PA means American. Oops, PA is American and PD means Delta. Okay, see how I'm color coding it to help keep me straight, because when I have to make sure to put this in the calculator the same. Okay, so I have my statistics here. Okay, so I could figure out the proportion of on-time flights. 250 divided by 300, I could do that math if I wanted to. Okay, so this is 83% on time. American, 185 divided by 213, that's 87% on time. They have different proportions. The question is it a significant enough difference to say that American has more on-time flights? Okay, and that's what we're going to use the calculator for. So we're going to use the calculator now. So we're going stat tests. This still is the 2-prop z-test. So we have 2 and their proportions. So it's the 2-prop z-test. And remember that it ends in test for as in hypothesis testing. 2, because we have 2 samples, prop means proportions. When you're trying to figure out which test to use, those little cues make a huge difference in making sure you're in the right place. X1, I said that's going to be Delta. So we're going to be putting in 250 out of that 300 on time. X2 is American, so 185 out of 213. And again, we're just looking for them being not equal. I'm going to show you what the calculate looks like. You can do draw or calculate. Okay, so here's the calculate, and you see here's our z-score, negative 1.09. Here's our p-value, 0.274. And see, it figured out the proportions that we just did, 0.83 and 0.87. And then it combines them all together for this sample, so ignore this. Okay, but remember, we just want the p-value. Okay, so this is our p-value. That's the probability of getting a sample, assuming there's no difference between the two. And that's a 0.27. So the question is, do we reject that hoe? Is the p low? And if so, let's reject that hoe. We do not reject the hoe because that P ain't low. That P has got to be really low. We got a P-value of 0.274, which is basically 27%. Is 27 less than 5%? Not even close. So we don't reject that hoe, which means there is not enough evidence to support the alternative, which means that statistically speaking, those airlines have the same on-time rate. Those of you that said yes to rejecting the hoe, remember it's all about if the P is low, lower than that level of significance. If the P is low, that hoe's got to go. Okay, when you have a P-value of 27%, that ain't low. Okay, so let's go to example 6 then. I've got a decision tree for you, and the second part of the final exam is only going to cover Unit 3, so lessons 18 to 23. This here is a decision tree for lessons 19 to 23. Which one we use depends on how many samples we use. Everything is dependent on how many samples we have, In each of these, I give you a whole bunch of scenarios, and I ask you to determine what test we're going to use. I think it's often easiest to start with the eliminating the options it can't be. Okay, so there's a few things that can help you eliminate it very quickly. If we're talking about averages or means, it's going to be a T. It's going to have a T in here somewhere. T, T, T. If it's a proportions, it's going to say Z and prop Z. Okay, and remember test because it's hypothesis tests. What we're doing today, we have 2 samples. And they're independent because Delta and American, 2 separate airlines. And we did proportions for both of those. So we were using 2 prop Z tests. Okay, and lesson 19, means versus proportions, tells you which test to use. Okay, and what we're going to do right now, next, is with 3 samples. And they're all going to be independent, and that's ANOVA. If they were dependent, there's another test, but we're not getting into that. And this is an introductory statistics class. Everything we do, there's always more to it. Okay, we're just sticking to kind of the basics for pretty much everything we do. Okay, so let's just do the first example, and let's do a couple of these. Oh yeah, and skip example 6. It's from lesson 20, and anytime you see something from lesson 20, just know you can skip it. For example, we're not going to have to worry about this because we didn't cover that. Remember, the only thing I'm asked to do is to determine what test I would use. Okay, so this is just practice in determining the test. So we're going to use this tree. So the previous study showed that 25% of people were in favor of Prop A, but a new sample of 600 people found 200 in favor. Has the proportion in favor increased? To answer the question, we would use which of these tests? What I start with, and what I mean by it's often easiest to start with eliminating the options it can't be, here I'm told to find the proportion. Has the proportion increased? And proportions have Z's and props. Look at all these options. I'm looking for the Z's, which tells me it can't be this one because that's a t-test. That's for means. It might be this one. That's a prop Z. This is a t-test. It's not going to be that because t is means. It's not going to be that next one. It might be this last one. So now the question is, do I have 1 sample or 2? Because that's really what the difference is. Remember, that's what the 1 means. This is 1 sample. This is 2 samples. Do I have 2 samples? This is just 1 sample, okay? But it is tricky. If you read the question, this says that it was 25%, now a new sample. I just have 1 new sample. Whereas if I was given 2 samples, I would be given the information for that second sample in this narrative, okay? Like I was given the Philly and Cleveland, or I was given the information for the sample of American and the sample of Delta. That was all in the narrative. That's what it's talking about when it's talking about 2 samples. Is there information here that you're given for 2 specific samples? And the answer is no. I'm just given this 1 sample of 600 people. And that's why it's the 1 sample. You can go and finish the rest of these. Start with this information here. Are you talking about proportions or means? Because then you can almost always narrow it down to only 2 or 3 instead of 5 options. It's never going to be the t-test on differences because we skipped that lesson. Okay, so you can actually go through all of those and cross out t-test on differences. It's not going to be that one. The only one that's the answer to is 6 because that's lesson 20. So I think what I'll do is I will put this at the beginning of the Unit 2, or excuse me, the final exam part 2.